Welcome to this episode of Robert's Creative Chronicles. So today I'm going to be discussing with you the basic concept of differentiation. Now, the first concept is the derivative of a constant function. Let y equals c, where c is any arbitrary constant. dy over dx equals limit of change in y over change in x as change in x approaches 0 equals 0. Hence, the derivative of any constant is 0. All real numbers, that is from a negative number to 0 to a positive number, all of them are all constants. So if you tell you to find derivative of any of these, the derivative is always 0. Or sometimes during partial differentiation, you assume that a certain function is a constant. Even then, if you differentiate it, it is 0. So what you need to know is the derivative of any constant is always 0. So the second concept, derivatives of the sum of functions. If y equals u of x plus v of x, then dy over dx equals the u over dx plus the v over dx. That means if they give you different functions, the sum of them, to differentiate, you first differentiate the first function, then you add the derivative to the derivative of the second function. As it is shown here, you differentiate u with respect to x, and you differentiate v with respect to x. So that is how you do the derivatives of the sum of functions. Then the third concept, the derivative of the difference of functions. If y equals u of x minus v of x, then the y over dx equals the u over dx minus the v over dx. It's the same thing with this one, but the only difference between them is you change the sign. You differentiate the first function, and you differentiate the second function, and you subtract them. And note that this u of x and v of x are all functions of x. That is why we differentiate them with respect to x. So they are functions of x. Now, the fourth concept, derivative of the product of functions. This one, you meet several functions that are products. You cannot escape this one, especially this one. You will do many differentiation that are products. And the way to do it, if y equals u of x multiplied by v of x, this dot is multiplied, then the y over the x equals v the u over the x plus u the v over the x. So this one, it simply means that you differentiate one of these functions. In this one, they differentiated u with respect to x, then you multiply it by the second one without differentiating the second one. Then you add it to the derivative of the other function multiplied by the other one that you did not differentiate. So in this one, you differentiate one of them and multiply it by the second function without differentiating the second function. Then you add it to the derivative of the second one multiplied by the other function that you will not differentiate. So here we differentiated u with respect to x, they did not differentiate v. And here they differentiated v with respect to x and they did not differentiate u. So that's what you're going to do. You differentiate one, you multiply it by the second function without differentiating it. Then you add it to the derivative of the second function and then multiply it by the other function without differentiating the other function. Now, the fifth concept, derivative of quotient functions. Now, if y equals u divided by v, where u and v are functions of x, then the y over the x equals v the u over the x minus u the v over the x, all divided by v squared. Now, what this means is that this v, you have to note the arrangement of this. If you put u here and v here, you you will not get the answer. So what this means is that the derivative of this function, which is division, two functions that are dividing each other, you multiply the denominator, which is the down one, times the derivative of the numerator, minus the numerator multiplied by the derivative of the denominator over the denominator squared. That is how we are going to do it. You should not change the arrangement. So this is how you find the derivative of a quotient function. That is two functions that are dividing each other. And finally, derivatives of composite functions. If y equals f in bracket g of x, then the y over the x equals the derivative of the outside function, which is f prime g of x, multiplied by the derivative of the inside function, which is g prime of x. Now, there are certain functions that are function of a function, like sine 3x is a function of a function. This kind of function, you have to differentiate the outside function, which is sine, and you have to differentiate the inside function, which is 3x, before you multiply them, before you find the derivative of that function. These are composite functions. So this is how you differentiate a composite function using this method. So these are the basic concepts of differentiation. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.